Hello and welcome to another yet interesting edition in medical biochemistry, where we'll be looking at glycolysis and effect of pyruvate. I'm your host, Dr. Morgan Epika Kama Jr. Okay, so we'll and the effect of pyruvate outline the reaction and other monosaccharides such as fructose and in glycolysis. Then number two, you must describe how 2,3-bis-phosphoglycerate is formed and its function. Then three, you should be able to explain the function and the regulation of glycolysis. Four, you should be able to describe the disease processes that arise from the deficiency of some enzymes involved in the metabolism of fructose and galactose and in the breaking down of glucose and glycolysis. Then the last objective, you should be able to discuss the effect of glucose, the effect of pyruvate under anaerobic and aerobic conditions. So now, what is the central role of carbohydrate metabolism? Alright, so to start with, glucose, the central role of glucose in carbohydrates metabolism. Number one, let me get the highlighter. Okay. The central role of glucose in carbohydrate metabolism. Number one, it is used that is under extracellular matrix as well as the cell wall polysaccharides. That is under the synthesis of the polysaccharide, the synthesis of the structural polymers. Remember, glucose is used especially in the synthesis of the polysaccharide as well as the cell wall of the plant cell wall, the one that is made up of cellulose, like those cellulose, those are just polysaccharides. Okay, then glucose is stored in form of glycogen, that is glycogen, starch and sucrose. Okay, so the storage form of glucose is glycogen, starch and sucrose. Then glucose can also undergo what we call oxidation via glycolysis to give us pyruvate. That's number three. Then number four, glucose can also go oxidation via pentose phosphate pathway to give us ribose 5-phosphate. Okay. Then part one. Okay, so under this part, I want you to focus only on the four major things. Number one, the reaction in the glycolytic pathway, that is the first part. Number two, the function of the glycolysis. Functions of glycolysis. Three, the regulation. And four, diseases involving glycolysis. So let's start with the first part. Source of glucose metabolized in the human body. So what are the metabolized in the human body? So we have the dietary source that includes carbohydrates such as starch, lactose, sucrose, the one that are found in food. Then glycogen, like that is just the excess glucose that is stored in form of glycogen in the liver. And in the liver we have the storage capacity of 90%, and in the skeletal muscles the storage capacity of 10%. Then from the synthesis of glucose from non-carbohydrates. Okay, from the synthesis of glucose from non-carbohydrates compounds in a process called gluconeogenesis. Okay, so this is just the synthesis of glucose from the non-carbohydrates compound, and such process is what we call gluconeogenesis. So these are the three major sources of glucose metabolism in human body. Now, what is glycolysis? That's a good question. Okay, so you might be wondering what glycolysis is. Glycolysis, in a nutshell, it is just a major pathway for glucose metabolism. It also involved in the metabolism of fructose as well as galactose. It is a universal pathway that takes place in the living organism, and it occurs in the cytosol. Now you need to understand the cytosol here, we're referring to the cytoplasm. So this cytoplasm within the living cell, it has the ability to divide when the cell is undergoing cell division. And the division of the cytosol, rather the cytoplasm, is what we call cytokinesis. Then it is also an important anaerobic pathway which takes place in the absence of oxygen, and its major role is to produce energy in form of ATP. Someone might be wondering what ATP is. So ATP, it is the adenosine triphosphate. Remember, we have ATP that is in the Krebs cycle, that is the tricarboxylic acid cycle, as well as the NADH, which is the nicotine-amide diphosphate hydrogen. Then there are 6 carbon sugar glucose that is broken down into 2 molecules of pyruvate and the 3 carbon compounds. These are just the major 2 phases of glycolysis. So there are 2 major phases that are involved in glycolysis. The first one is called the preparatory phase, and the other name for the preparatory phase, it's the investment phase. And the second one, it's called the payoff phase. So the reason why the preparatory phase is called the investment phase, because on reaction number 1 and reaction number 3 of the glycolytic reaction, we have the investment of ATP molecule. Okay, let's take a look at what I'm explaining about on the diagram, on the next diagram here. Okay, so we'll start by looking at the preparatory phase. Preparatory phase, these are the 10 enzymes catalyze reaction in the glycolysis. The first 5 reactions constitute of the preparatory phase, or rather the investment phase, where glucose becomes phosphorylated and it is split into 2 molecules of glycerolhaldehyde 3-phosphate. And the second phase is called the payoff phase, where energy in form of ATP is produced. So this is the major cardinal important info that you need to grasp as we make progress to the next section. Okay, so now the first reaction, it's called phosphorylation. So the phosphorylation of glucose, where we say glucose 6-phosphate catalyzed by the enzyme called exokinase, which requires the cofactor that is the magnesium 1. So reaction 1, what do we have? We have glucose reacting with ATP, 1 ATP molecule, to give us glucose 6-phosphate plus ADH. So ADH there, that is the adenosine diphosphate. Okay, the enzyme that catalyzes the first reaction. And remember, reaction number 1, it's a forward reaction. And the enzyme that catalyzes this reaction, it's called exokinase. Okay, so it's important. The importance of phosphorylation reaction is that once glucose is phosphorylated to glucose 6-phosphate, it cannot leave the cell. Hence, exokinase is the enzyme that is found in the cell of all tissue. All right. So in the liver, apart from exokinase, so within the liver itself, we've got this enzyme called exokinase. So apart from exokinase, there is also glucokinase. So meaning that if exokinase hasn't catalyzed this reaction, meaning that we'll have another enzyme called glucokinase, which has the same similar properties and function as well as which are similarly related to exokinase. It can also facilitate this kind of a reaction, which is the first reaction during the preparatory phase, which is called the phosphorylated glucose to glucose 6-phosphate. Then exokinase, it has the high affinity for glucose. So when we say high affinity, it simply means that it has it catalyzes fast because it is prone to glucose, and it has the low Km value, while glucokinase, it has a low affinity for glucose and it has the high Km value. So these are the 2 differences that we should take note of between these two enzymes, hexokinase as well as glucokinase. Hexokinase, it has high affinity for glucose and it has low Km value, while glucokinase has a low affinity for glucose and it has a high Km value. Reaction number 2. Reaction number 2, what do we have? We have glucose 6-phosphate. It undergoes a reverse reaction to give us glucose 6-phosphate. So meaning that an aldo, then there is an aldo-ketose isomerization. So this one is an aldo-ketose isomerization reaction. And the enzyme that does this catalyzation is called phosphoexose isomerase. So the enzyme that does this catalyzation is called phosphoexose isomerase. Then reaction number 3 is the second phosphorylation reaction where fructose 6-phosphate is phosphorylated to fructose 1,6 bisphosphate. And the enzyme that does the conversion of this enzyme or this reaction is called phosphofructokinase 1. Okay, phosphofructokinase 1. So phosphofructokinase 1 catalyzes the rate of the limiting steps in the glycolysis that regulates the pathway. Then we also have what we call an allosteric. Remember, an enzyme has got two sites. The site where the substrate binds, it is called the active site. And the site that remains, it is called the allosteric site. Okay, so an allosteric site, that is the positive allosteric effect. So the positive allosteric effect for this enzyme called fructose phosphokinase 1, it is ADP, which is adenosine diphosphate, and AMP, which is adenosine monophosphate. And the negative effect and the negative effectors are ATP and citrate. So the positive effect are ADP and AMP. Then the negative effects include ATP and citrate. Reaction number 3. Fructose 6-phosphate reacts with ATP to give us fructose 1,6 bisphosphate plus ADP. So in here, what do we have? We have fructose 6-phosphate reacting with ATP, giving us fructose 1,6 bisphosphate. Then okay. Okay, that is on reaction number 3 where we have fructose 6-phosphate plus ATP giving us fructose 1,6 bisphosphate plus ADP. Then the enzyme is called aldolase. Then reaction number 4, we have the 6-carbon sugar, that is fructose 1,6 bisphosphate, is split into 3 carbon sugars, namely glycolyl 3-phosphate and dihydroxyacetone phosphate, and the enzyme is called aldolase. Okay, the enzyme is called aldolase. So reaction number 4, what do we have? We have fructose 1,6 bisphosphate giving us glycolyl 3-phosphate plus dihydroxyacetone phosphate. Reaction number 5. Okay, reaction number 5 consists of the ketose aldose isomerization, where dihydroxyacetone phosphate is being isomerized to form a glycolyl 3-phosphate, and the enzyme is called triose phosphate isomerase. So this ends this marks the end of the preparatory phase where glucose 6-phosphate has been converted to 2 molecules of glycolyl 3-phosphate. Then reaction number 5, okay, so reaction number 5, we have dihydroxyacetone phosphate giving us glycolyhaldehyde 3-phosphate. Okay, so these are the reaction of glycolysis, starting from reaction number 1 up to reaction number 5. This phase is what we call the preparatory phase. So the preparatory phase, that is the phosphorylation of glucose and its conversion to glycolyhaldehyde 3-phosphate. So the first priming reaction, we have glucose molecules reacting with one ATP molecule. That's a forward reaction. Then the enzyme that catalyzes this reaction is called exokinase. And then the product that we get to have, it is glucose 6-phosphate. Okay. Then glucose 6-phosphate undergo the second reaction, which is the reversible reaction, to give us fructose 6-phosphate. Then the enzyme that does is called phosphoexose. Then reaction number 3, we have fructose 6-phosphate undergoing fructose 6-phosphate plus ATP undergoing a forward reaction, giving us fructose 1,6 bisphosphate. Then the enzyme that does the catalyzation, it is called phosphofructokinase 1. Now remember, this is the second priming reaction. Okay. Then reaction number 4, where we get to have fructose 1,6 bisphosphate, gives us the products which are glycolyhaldehyde 3-phosphate plus dihydroxyacetone phosphate. The enzyme that does the catalyzation, it's called aldolase. Then the cleavage of the 6 carbon sugar phosphate to 3 carbon sugar phosphate. Okay, so this one is done from 6 carbon sugar phosphate to 3 carbon sugar phosphate. Okay, so when that is done, then we get to have the dihydroxyacetone will react, a reverse reaction, giving us glycolyhaldehyde 3-phosphate. And the enzyme that does the fifth reaction, it's called triose phosphate isomerase. Okay, so this is how the preparatory phase is done. There are 5 enzymatic reactions. Okay, so the enzyme that catalyzes the first reaction, it's called exokinase. Enzyme that catalyzes second reaction, it's called glucose 6 isomerase or phosphoexose isomerase. Then the enzyme that catalyzes reaction number 3, it's called a phosphofructokinase 1. Then the enzyme that catalyzes reaction number 4, it's called aldolase. Then the enzyme that catalyzes reaction number 5, it is called triose phosphate isomerase. Okay. Now let's go to this brings us to the second phase of the glycolysis, which is called the payoff phase. So the payoff phase is also known to be the yielding phase, where we get to harvest from the investment that was made in the first reaction. So in here we have in the payoff phase, there are 2 molecules of glycolyhaldehyde 3-phosphate. So there are 2 molecules of glycolyhaldehyde 3-phosphate, which will produce the energy in form of ATP in the 6th reaction. Okay, 6th reaction. So the 2 steps of oxidation phosphorylation reaction in the enzyme is glycolyhaldehyde 3-phosphate dehydrogenase. Okay, for these 2 phases of oxidative phosphorylation, the enzyme is glycolyhaldehyde 3-phosphate hydrogenase. Then in the first step, the aldehyde group of the glycolyhaldehyde 3-phosphate becomes oxidized to carboxylic acid group. And the second step, we have the carboxylic acid requires a phosphate group in form of an inorganic phosphate. And in reaction number 6, we get to have glycolyhaldehyde 3-phosphate plus NAD, which is the nicotine amide dye, plus PI, that is an inorganic phosphate, giving us 1,3 bisphosphoglycerate, as well as NADS plus H, that is the nicotinamide dihydrogen plus hydrogen atom. Okay, Then the substrate level for phosphorylation. So the seventh reaction is a substrate level phosphorylation reaction. What do I mean a substrate level phosphorylation? It simply means that the enzyme that does the catalyzation of the seventh reaction is called the phosphoglycolate kinase. Meaning it really gives us what we call 1,3 bisphosphoglycolate, that is the high energy compound with a G0, okay, that is the energy of negative 49.3 kilojoules of energy per mole, and it is used to synthesize ATP, that is under reaction number 7. To have ATP, 2 molecules of ATP that are produced. We have reaction number 7, we have 1,3 bisphosphoglycolate plus ADP, giving us 3 phosphoglycolate plus ATP. Okay. Then 8th reaction, it is catalyzed by phosphoglycolate mutase. So the 8th reaction is catalyzed by phosphoglycolate mutase, and there is a shift of a phosphate group from the carbon atom number 3 to carbon atom number 2, and the 3 phosphoglycolate is converted to 2 phosphoglycolate. Okay, then on the reaction there, reaction number 8, we have 2 phosphoglycolate giving us, we have 3 phosphoglycolate giving us 2 phosphoglycolate. Okay, then reaction number 9, a water is removed from 2 phosphoglycolate to form phosphoenolpyruvate. So phosphoenolpyruvate is formed when water is removed, that is the dehydrogenase reaction. Water is removed from 2 phosphoglycolate to form phosphoenolpyruvate, and the enzyme is enorase. Then the reaction number 9, we have 2 phosphoglycolate giving us, undergoing a reverse reaction, giving us phosphoenolpyruvate plus water, and then the enzyme is enorase. Then the last reaction, which is the 10th reaction, this one is called the second substrate level phosphorylation, where phosphoenolpyruvate, a high energy phosphate compound with a G0 of negative 61.9 kilojoule per mole, it is used to synthesize ATP, that is the adenosine triphosphate, and the enzyme is called pyruvate kinase. Okay, so that's the last enzyme that catalyzes the 10th glycolytic enzymatic reaction. So reaction phosphoenolpyruvate plus ADP, giving us pyruvate and 2 molecules of ATP. Okay, so this brings us to the last reaction of the glycolysis. Now let's look at the overview. So from the overview, here we have glycerolhaldehyde 3-phosphate plus dihydroxyacetone phosphate, giving us what we call 2-glycerolhaldehyde 3-phosphate. Then the enzyme that does the catalyzation of this is called triose phosphate isomerase. Now, B, that is the pair of phase. So the pair of phase, this is the oxidative conversion of glycerolhaldehyde 3-phosphate to pyruvate and the coupled formation of ATP and NADH. Then we get to have oxidation and phosphorylation. Then the first ATP forming reaction, okay, that is at reaction number 5, reaction number 7. So the first oxidation and phosphorylation is done when 2-glycerolhaldehyde 3-phosphate undergoes a reverse reaction with 2 NAD and 2 inorganic phosphate, giving us 2 NADH plus 2 hydrogen and 1,3 bisphosphoglycolate. Then the enzyme that does the catalyzation of this one is called, the 60th reaction is called glycerolhaldehyde 3-phosphate dehydrogenase. Then reaction number 7, we have 1,3 bisphosphoglycerate giving us 3 phosphoglycerate, then and 2 ATP molecules. So there is 2 ATP molecules are produced. Then the enzyme that does the catalyzation is called phosphoglycerate kinase. Then at this stage we have the ATP forming reaction, substrate level phosphorylation. Then reaction number 8, we have 3 phosphoglycerate giving us 2 phosphoglycerate. The enzyme that does the reaction of the catalyzation of this reaction is called phosphoglycerate mutase. Okay. Then we have reaction number 9. So reaction number 9, it's also a reverse reaction where 2 phosphoglycerate undergo a reverse reaction to give us phosphoenolpyruvate. Now remember, from 2 phosphoenolpyruvate, we're removing water molecule. 2 water molecules are removed from 2 phosphate glycerate. 2 water molecules are removed, giving us phosphoenolpyruvate. The enzyme that does the catalyzation is called enolase. Then the final reaction, we get to have 2 phosphoenolpyruvate plus 2 ADP, giving us 2 ATP as the product, as well as 2 pyruvates that are produced. Then the enzyme that does the catalyzation of the 10th reaction, it is called pyruvate kinase. So meaning that at the second ATP forming reaction is done at reaction number 10 at the substrate level phosphorylation. Now, what is the net equation of glycolysis? So in summary, just to come up with the net equation of glycolysis, we have glucose plus 2 NAD plus 2 ADP plus 2 inorganic phosphate. So this one gives us 2 pyruvate plus 2 NADH plus 2 hydrogen plus 2 ADP plus 2 water molecules. So the overall process of glycolysis, so one molecule glucose is converted to 2 molecules of pyruvate plus 2 molecules of ATP and 2 molecules of NADH plus hydrogen. Now, let's look at 2,3 bisphosphoglycerate shunt. So this is a shunt. 2,3 bisphosphoglycerate shunt. What is it? So the 2,3 bisphosphoglycerate from 1,3 bisphosphoglycerate located in the red blood cells, the erythrocytes. The enzyme is a mutase. The enzyme is a mutase. So this one is done on reaction number 3, where 1,3 bisphosphoglycerate gives us a yield of 2,3 bisphosphoglycerate. The 2,3 bisphosphoglycerate can later on be converted to 2 phosphoglycerate, which can enter the glycolysis in the cytosol, and the enzyme is a phosphatase. Okay, so the enzyme is phosphatase. Then reaction on the reaction we have 2,3 bisphosphoglycerate plus water molecule, giving us the product 3 phosphoglycerate plus an inorganic phosphate. Now, in summary of these enzymatic reaction, we have 2,3 bisphosphoglycerate shunt. It starts with glyceraldehyde 3-phosphate, which is later on converted to 1,3 bisphosphoglycerate. Then this one, it can be converted in 2 phases. 1,3 bisphosphoglycerate can give us 2,3 bisphosphoglycerate, which can also yield 3 phosphoglycerate, and 3 phosphoglycerate is what gives us 2 phosphoglycerate. 2 phosphoglycerates gives us phosphoenolpyruvate. Then from phosphoenolpyruvate we get to have pyruvate itself. Okay, so this is just the shunt of 2,3 bisphosphoglycerate. Now, 2,3 bisphosphoglycerate is produced in large quantity in the red blood cells in glycolysis. It is a negative allosteric effector of hemoglobin, and it inhibits oxygen binding to hemoglobin. So meaning that this one just inhibits the binding of oxygen to hemoglobin, and it regulates the affinity of hemoglobin for oxygen and facilitates the delivery of oxygen to the tissue. Alright, so in conclusion, what I'm trying to say here is that the 2,3 bisphosphoglycerate is produced in large quantity in the red blood cells in glycolysis, and the effect of 2,3 bisphosphoglycerate that is produced in large quantity in the red blood cells in the glycolysis, it has a negative allosteric effector of hemoglobin, and it inhibits oxygen binding to hemoglobin, so meaning that oxygen will not bind to hemoglobin, and meaning it will also regulate the affinity of hemoglobin for oxygen and facilitate the delivery of oxygen to the tissues. Now, this brings us to regulation of glycolysis. How is glycolysis regulated? Regulation of glycolysis is done through the following three enzymatic that catalyze the irreversible reaction. So meaning these are just forward reaction. They are irreversible reaction where exokinase, this one is seen on reaction number 1, reaction number 3, and reaction number 10. So reaction number 1 is a reversible reaction, that is just a forward reaction. Reaction number 3, it's also a reversible reaction. And reaction number 10, it's also a irreversible reaction, which is just a forward reaction. So the enzyme that catalyze the three reactions are exokinase, phosphofructokinase 1, and pyruvate kinase. Alright, so exokinase is inhibited by glucose 6-phosphate through the product inhibition. Then the second one we have phosphofructokinase 1, that is done at reaction number 3, which catalyzes the rate limiting step, committed step. It is an allosteric enzyme, that is the positive allosteric effectors are AMP, that is adenosine monophosphate, and the negative allosteric effector are ATP and citrate. So these are the activators, the positive effector. Then the third enzyme that facilitates the regulation of glycolysis, which is pyruvate kinase. We have it catalyzes the last reaction in glycolysis, a substrate level phosphorylation. That is, ATP inhibits the enzyme while ADP activated the enzyme. Okay, so ATP inhibits the enzyme, then ADP activates the enzyme. Okay, diseases that are involved in glycolysis, we have exokinase deficiency. So if a person is having exokinase deficiency, meaning that glucose will not be converted to glucose 6-phosphate. So the diseases that we'll have is that the last enzyme in glycolysis and all glycolytic will be reduced. There is a reduction of ATP in the mature red blood cells, which depends on the glycolysis for energy production. 2,3 bisphosphoglycerate production is also reduced in mature red blood cell production, and this increases the oxygen binding to hemoglobin. Pyruvate kinase deficiency. So this is the last enzyme in the glycolysis, and all intermediate accumulates including 2,3 bisphosphoglycerate as a result of oxygen binding to hemoglobin is reduced. Pyruvate kinase catalyzes the reaction involving in the ATP adenosine triphosphate production, and the pyruvate kinase deficiency is therefore reduces ATP production. Okay, so pyruvate kinase deficiency reduces ATP production. Mature red blood cells are mostly affected because they depend solely on glycolysis for ATP production, ATP maintenance of the integrity of the red blood cell membrane. Pyruvate kinase deficiency causes hemolysis, that is the busting, that is the destruction of the red blood cell before their time, leading to hemolytic anemia. Okay, so this brings us to the end of this session for today. And if you at all you have any questions, ensure you just write them down in the comment section below. Ensure to subscribe to my YouTube channel and also hit the notification button to get updated for each content that I post and share. Thank you.